Hello students, and welcome to our final video here for calculus. We are looking today at arcs and sectors. We're going to come back around a little bit here to our introduction to radians. So, we only mentioned quite briefly earlier on that radians are a ratio, and they are ratio of an arc length to a circle's radius. Okay, so it's the arc subtended by that angle, right, divided by the length of the radius. An arc being part of the circumference of a circle, the radius being the distance from the center of that circle to the circumference. Now, two little formulas here to remember. They're quite straightforward. They are much easier, really, when we deal with radians. This is part of the reason that we work in radians. Is the length of an arc is simply r times theta, the radius times the angle at the center. Right, wonderful and easy. And the area of a sector, right, being like a piece of pie, the area of a sector, half r squared theta. Right. And if you're really observant, you might notice that if I differentiated this expression here with respect to r, I'd get r theta. What a coincidence. Perhaps something for another day. Anyway, let's jump into some examples. The area of a sector that has a radius of 5 and an angle at the center of 2 pi and 3. Area, half r squared theta. R is 5, theta is 2 pi and 3. What can I do here? I could cancel those 2's, and I'm going to get 25 pi over 3. Right. Square units. Another example, the perimeter of that sector. Well, let's just draw a little picture here of a sector. The perimeter will include the arc length, but also 2 radii. So, the perimeter is going to be r theta, that's how I calculate the length of that arc, plus r again, or r theta, so 5 being the radius, times the angle here at the center was 2 pi and 3, plus 2 lots of 5, my 2 radii, and that gives me 10 pi and 3 plus 10, or if you like, 10 outside of pi over 3 plus 1. Rightio. That's about it. Not terribly difficult, but something new. And means we've got to practice it. If it doesn't make any sense, make sure to hit me up in class. But just a quick recap here. Arc length is r theta. The area of a sector, half r squared theta. Rightio, that's all. I will see you ready for the next unit of work. Thanks, students.